In this video, we're going to look at how we can change the subject of a formula. Now, if we have a look at this one here, we will see what the subject is. So V equals U plus AT. This is a formula you'll maybe see in physics, where your final velocity is equal to your initial velocity plus your acceleration and your time. So V is the subject because it's V is equal to the rest of it. Here, I is equal to the rest of the formula, so I is the subject, and here S, the displacement, is equal to ut plus a half at squared. Now, it's quite useful at times to change the subject of the formula. If we have a look on down, we'll see we're going to use the inverse operations method to do this. So if we know what the original operation is and we know what the inverse of operation is, it will help us to go about changing the subject. So if you have plus or minus, the opposite of plus minus is minus plus. If you have times, the opposite of times is divide. If you have the square root, the opposite of square root is squaring. If you cube root, the opposite of cube root is cubing. And these work both ways. So the opposite of minus plus is plus minus, opposite of divide is times, opposite of squaring is square root, opposite of cubing is cube root, and so on. And there's lots of other opposite pairs or inverse pairs as well. So we're going to go on now and look at a few examples. It says in this one, make x the subject of each formula. This one, we have to make x a subject. So first thing we've got two things going on. First thing that's happening to the x, the most immediate thing is it's being multiplied by 2. Then you're taking away p. So the last thing we did was take away p. So that's the first thing that we reverse. So the opposite, or the inverse of taking away p, is adding p. So you have 2x is equal to p, 2x is equal to t plus p. So now the only thing that's happening to the x is being multiplied by 2. So the opposite of multiplying by 2 is dividing by 2. So how I write this is t plus p all divided by 2. Now try and avoid, if you can, try and avoid writing it as t plus p divided by 2, because that looks quite like t plus p over 2, which is a different thing. So if you can, try and use a good horizontal line here between your numerator and your denominator. So a good horizontal line, just to be really clear. So I'll rub out this one, which I don't like. A good horizontal line is what we're looking for. Example B, there's only one thing happening to the x here, so it's actually an easier one. It is x being multiplied by m. So the opposite of multiplying by m is dividing by m, and that's it. Example C, and I'll show you a couple of ways of doing example C. So the first way, we have two things going on. You're multiplying by minus d, and then you've got a c on its own here. So that really is a plus c, so it's as if you're multiplying by minus d and then you're adding c. So the first way, I'll get rid of that, but the first way to reverse this is bring the c over first of all. You'll have minus dx is equal to m minus c. And then we're going to divide across by the minus d. So that's what we're going to have. And then a nice wee trick. You've got a positive thing, and then we have two negative things. So what you can do is just multiply everything in the bottom line by minus 1 to make that positive d, and multiply the top line by minus 1. So if you multiply minus c by minus 1, you will get plus c. And if you multiply m by minus 1, you'll get minus m. So you'll see in a minute when I do the second method, the alternative method, this is still right. So the other way we could do it is you could bring your minus d across. So switch your minus d to the other side. So you'll have dx plus m, and then bring the m across. So you'll have c minus m is equal to dx. And then just divide across by the d. So c minus m all divided by d is equal to x, which of course you could write just as c minus m all divided by d. So you can see two different methods, but they're both just as good. So whichever one you prefer. I have to say I prefer the first method, but I know most people prefer the second method. Okay, example D. And we could do two methods for this. I'm only going to give you one. So I'm going to say minus dx is equal to m minus f minus b. And then I'm going to divide across by the minus d. So I'll have m minus f minus b all divided by minus d. So similar to the first example we did like this, I'm going to multiply the top line by minus 1 and the bottom line by minus 1. So it'll become, I'll just put them in a nicer order, b plus f minus m all divided by d.